Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off on the topic, okay, rational functions and partial fractions. Rational functions and partial fractions. Remember, in our previous meetings, okay, we were looking at how to resolve rational functions. But so far, okay, we dealt with questions that the rational functions, okay, were all proper. Okay, so what we are going to do today will be how to deal with a situation where your rational function is what? Improper. Okay, so today's lesson is going to be lesson what? Lesson 4. So in the lesson 3, lesson 2, okay, where we were resolving, okay, we dealt with only proper. Okay, so now this lesson is really for improper, how to deal with that. Okay, all right. So quickly, let's go and see, okay, how we can deal with the improper situation. So our fourth worked example, which covers the situation that I just mentioned. Okay, resolve the following into partial fractions. So as usual, solution. We don't have anything salient to underline. So we write solution. Our major question number, we do have 4. Okay, our minor question number A. Okay, then you extract what you are asked to resolve, which is this, okay, fraction. Okay, so at this point, okay, what do we do? First question, proper or improper? Indirectly, I've answered that question because I told you that this, okay, question 4 or worked example number 4, okay, is all about improper fraction. So degree of the numerator is 2, that of the denominator is 2. Is that not it? So making it what? Improper. Once it's improper, okay, you cannot write the identity straight away. Remember, I told you when you were writing the identities, okay, you had this, okay, as one of the slides, and I explained that. So I will go back, okay, and this is it. Remember, when we were expressing rational fraction to partial fraction identities, which is key in your resolution, we said if the rational function is proper, okay, proceed to write the corresponding identities, which I said you consider the denominator. That will help you write the corresponding identities. However, look at 2. If the rational fraction is improper, okay, we didn't say you should proceed to write the identity. Okay, before you can write the identity, you need to write what? Your expression, okay, or which is your improper rational function in the form quotient plus remainder over the divisor. So anytime you need a quotient, you need the remainder, the divisor, okay, you know we have to use the long division. Okay, if the question is demanding or requesting for only the remainder, then we know we have to use the remainder theorem. But here we said we are supposed to express it in the form quotient plus remainder over divisor. Okay, so the long division is what must come, okay, to mind. However, in some books, okay, they won't write quotient here, they will write polynomial. Polynomial to replace what? The quotient, because the quotient will always be a polynomial. And instead of, okay, writing remainder over divisor, this one, they will write this one as what? Rational, okay, function. Okay, which always will be proper anyway. Okay, so in some books you see polynomial plus a rational function, and that rational function will be proper. Always. Okay, so in this situation, we are going to use exactly what you have there. Okay, so after that, what do? You take the proper fraction, which I said will be this. Okay, so like I said, okay, and write the corresponding identity. We know how to write the identity when our rational function is proper. Okay, then after that, you come and add, okay, that identity to your quotient. Okay, however, after doing that, we don't end there. Now we are resolving. Once you know the identity, then you move on, okay, from the identity. Okay, so our first note here will be how to write the identity in the situation where your fraction is improper. Okay, after that, then we'll look at the resolution. And the resolution will come in when we find the values of the letters that we introduce in the identities and we substitute. Is that clear? Is my point well made? Okay, so now let's go and use the
Yes.
concept that I just walked you through. Okay, subject this one through that. Okay, so let's see. Proper. Okay, improper, and we've established that it's improper. Once it's improper, we cannot write the identity straight away. We have to write this one as a sum of what? A quotient plus what? Remainder over the divisor. Polynomial plus a rational function. So we need the long division. So we set up our long division. So this will be equal to set up your long division. Thankfully, you come and write your divisor, okay, here. And your divisor is written out completely in the standard form. So you write it s squared minus what? 3s, forgive me, okay, plus 2. Okay, and okay, so before you write your equal to, you have to leave a line. Okay, here you are leaving a line because you know that per experience the quotient will occupy that line, so no line is left what unused, the same. So quickly let me go and clear what I have there. Okay, all right, so now it's looking okay the way I want it to look. Then we come to our dividend, which is supposed to be here. The dividend is written in the standard form, all right, but not completely, because it's degree 2. You should have 3 terms when it's written out completely. So we introduce the linear term that is missing, so that will give you s squared, okay, s squared plus 0x then plus what? 1. Is my point well made?
Yes, please.
Okay, great. Okay, so now we know we've set up. So let's go and continue our long division. S squared over S squared, okay, will give us 1. So we come and write 1 here. Okay, then what do we do? Okay, multiply this by that. So we are going to get S squared, okay, times this. So this will give you minus 3x, okay, then plus 2. Okay, you come and subtract. Okay, so you can see that we are doing rational function, and here is the case we are using polynomial long division. So I told you that they are related. Okay, so connected. So your long division, okay, needs to be on point. So now what do we have? You subtract. Always the first will go. So this will give you 4x. Okay, then this will give you 1 minus, okay, 2 will give you minus 1. Okay, so at this point, what do you do? Okay, the degree here, okay, obviously you can see it's lower than the degree here. So this your new dividend becomes your remainder. So you stop here. So it means what I have here will be equal to, okay, so please listen and listen well. So it will give me 1, which is my quotient, plus my remainder, which is 4x minus 1 over my divisor. And my divisor is s squared, okay, minus 3x, okay, plus 2. So what we were asked to do, which was express the given rational function in the form your quotient plus the remainder over the divisor, which is your polynomial plus the rational function we have. So the first one catered for. Now the next step, what are we supposed to do? We said we come and take what? The rational function that we have there, the proper, which is this. Okay, because this will not be rational. There wouldn't be any denominator. It will always be 1. Take this one, write the identity of this one, then come and attach it to this. So it means we are going to take this, okay, then write the identity of this, because this is proper. We know how to deal with the proper in terms of the identity. So you come and write taking. All right, okay, Prof. Henry.
So please, it's supposed to be
Very
3x
good.
plus
You are
1.
the only one who is following. You are the only one who is following. So you can see that immediately any of your quotients, as for the remainder, that one was given. What you need to, did I say the remainder, the divisor, that one is given. So I don't think anyone will get it wrong. If there will be anything wrong here, then it will come from your remainder or your quotient. So if any of them is wrong, you have to be very careful. Everything will be wrong going forward. So be very, very careful. Okay, so obviously this will be 0x plus 3x. So that will give you, okay, 3x, not 4x. And I don't know why you were quiet. Okay, take notes. So this shouldn't be, we are experts, and this was intentional. That's why immediately he started saying that I knew that was what he was drawing my attention to, because I was expecting at least one of you to draw my attention to that. Okay, so quickly I will go and do the needful. So I have made my point clear. All right, if you didn't talk, I would have continued, ended before drawing your attention to that, so that we will know that we've all wasted our time. Okay, you have to be very careful. Okay, if you follow whatever I'm doing, you should be able to draw my attention if there is something wrong. So quickly, this will be 3. Let me go and effect that change. This will also be 3. Okay, that's if you write 4, you are doomed from there. Okay, so 3. Okay, 3. So all correct now, is that not? So taking now your 3x minus 1 all over your x squared, okay, minus 3x plus 2. Okay, this is what we are going to get. Okay, so at this point, we need to, this is proper. So we need to write the identity of this. And once it's proper, you come to the denominator. It's quadratic, which possibly is factorable. So let's see if you can factorize the denominator. Factors of plus, okay, 2, that's when you add, you get minus 3. You multiply, you get, okay, plus 2. And that will be minus 2 minus 1. Am I right? Okay, so we are not going to do our factorization. Okay, if you want to use the grouping here, you pick it out, go and factorize as your rough work, then you import. Otherwise, this is a special situation. The leading coefficient is 1. So I can factorize, okay, without showing my factorization by group. You remember the trick. So you get 3x minus 1. The factors in the denominator will be, you use, so you know it will be, 1 will be x in brackets. Okay, then the other will also be x in brackets. So the factors we said -2, -1. So I will write -1, -2. The other doesn't really matter. So this will be how you factorize that. Point well made, my professors.
Yes, please.
Okay, so at this point, you can see that we are still getting the identity of this. We are not done. But once you factorize, you know you have 2 non-factorable linear factors. So that should tell you the number of fractions that will come from this. And that will help you write your identity. So at this point, I'm going to write my identity. So I use my identity sign. If you use equal to, okay, take notes. Well, you know what will happen to you. So your first fraction, the denominator will be x minus 1. Okay, plus your second fraction, the denominator will be what? X minus 2. Okay, linear numerator will be a constant. Linear numerator will be a constant, so b. So at this point, remember, single fraction all the way. So single fraction, your LCM will be the same as the factorized form. So x minus 1, okay, x minus 2. Okay, so at this point, then you ask yourself, this will go into your LCM, x minus 2 times a. So it will be a into x minus 2. I hope you are following my professors.
Yes,
Then
please.
this will go into this x
Yes,
minus
please.
1 times b. So it will be b into x minus 1.
Yes, sir.
Okay, so at this point, single fraction, what do? We equate the numerators. So the numerator here, which is 3x minus 1, should be equal to the numerator here, which is a into x minus 2, okay, plus b into what? X minus 1. So here, all the factors are linear factors, okay, and you have 2 linear factors with 2 unknowns. So it means that direct substitution using the factors will be enough. Okay, so let's see. I want to start with a smaller number. Okay, you can go for this. X is equal to 2. Okay, x is equal to 1, but I want to start with a smaller number. It doesn't really matter the order. I've already told you. So if x is equal to 1, okay, remember I use this factor first. Okay, then followed by, so then I'm going to get 3 into 1 minus 1 is equal to a into what? 1, okay, minus 2. Prof. Gabi, I'm coming. Plus b into 1 minus 1. Okay, so Prof. Gabi.
Sir, please, the x is equal to 1.
You generate it from the denominator, or it was just a random guess?
Hey, Prof. Gabi. Eh? So all that I've been saying so far, you will use the cover up method. You use your linear factors. Okay, so if you want to cover up the b, so it means you want to eliminate the b. How would the b go? B will go only when this is 0. So you equate this one to 0 and you solve for your x. So that will tell you the s that you are supposed to substitute for the b to go. Same for the a. Okay, so you get it from the factors here. After exhausting the linear factors and you realize that you've not found all your unknowns, then you resort to the what I call the liberty values.
Okay.
You get the point?
Yes, sir.
Okay, all right. Okay, so I will pull you once I realize that okay, you didn't think through the question. I will pull. As for that one, there I will pull your legs more. That one is constant. It's a K. All right. So now what do we do if you have understood? But that shouldn't stop you from asking questions. I've told you. Okay, it ends here. That's all. All right. So 3 times 1 is 3 minus 1. So that will give us what 2. Okay, and that should be equal to a into 1 minus 2. That will be minus 1. So I will get minus a. Minus 1 times a is minus a. Okay, this will go. It will give you 0. So in effect, a will be equal to 2, negative 2. I will move this one here, move this one here. All correct. Someone can choose to divide by negative 1. It's allowed. Only that you will use more lines and therefore write more. Is that clear? So A down, B to go. So B, if x is equal to which value? Which values?
2.
2, very good. Okay, so we are going to get 3 into 2 minus 1 should be equal to A into 2 minus 2, okay, plus B into 2 minus 1. Okay, so at this point, 3 times 2, 6 minus 1, so 5, should be equal to A. This will go because that's what contains that factor that you set to 0. Then this will give you 2 minus 1, 1. Okay, times B, so B. So here you have your value of B straight away. So you know A and B, so comfortably you can say that this implies that you can say therefore this is equal to, because you were not asked to resolve this, so you cannot conclude with this. This only a means to an end. So therefore, the partial fraction of this, did I say partial fraction? Yes, partial fraction, forgive me. The partial fraction of this. And here, because we were asked to write, okay, what you have there, resolve into partial fraction, that's the more reason why we had to go on to find the A and B. If we're just asked to write the identity of this one, okay, the partial fraction identity, then you would have concluded this way. After getting the partial fraction of this, then it will be 1 plus the overall. The partial fraction of this would be 1 plus your A over your x minus 1, then plus the B over the x minus 2. That will be the partial fraction of the whole of this. Identity, I should say. The partial fraction identity of that. But if you go on to find the A and B, then you know there's that partial fraction. That's what we have. So now we know the A and B, but that is the partial fraction, okay, of this. So you write, this implies that 3x minus 1 over x squared, okay, minus 3x, okay, plus 2 will be equal to, okay, now A is negative, so I can't start with A. Let's look at the B. B is what? Is it positive? It's also negative, or it's positive. So 5 over, okay, so I will start with this. So 5 over x minus 2. So x minus 2. Then minus what? 2 over x minus 1. But I'm not done. Remember, I was not asked to, okay, write the partial fraction of this. This only a means to an end. So it means my overall partial fraction, therefore, what I was asked to resolve, which is this s squared plus, what was it? Yes, s squared plus 1 all over, okay, all over s squared, okay, minus 3x, okay, plus 2 will be equal to, remember your quotient plus the resolution of this. So your quotient is 1 plus the resolution of this, which is what we have here. So plus 5 over x minus 2 minus what? 2 over x minus 1. All correct. Is my point well made, my professors?
Yes, sir.
Okay, however, let me say this. Okay, because remember I said you don't conclude with an expression where your first term is what? I mean, you have at least one of the terms being positive and you conclude with your first term being negative. Okay, remember in this case, if you have started with negative 2 over x minus 1 plus 5 over x minus 2, that is not your conclusion. Okay, so in this case, you can write it. But you know, in your conclusion, this is positive. So if you maintain it, remember this will be your first term. This will always be your quotient, will always be the first term of your conclusion. So because that is positive, I don't mind how I will arrange it, whether I will start with positive or negative, because my overall or my final answer, I know that I will start with positive. So this will not be my first term. None of this will be my first term in my final answer. You get the point. So I'm not worried. But I did this just for consistency's sake. Okay, so that in a situation, so you can equally adapt. But I just want you to say that you shouldn't follow it to the latter. You get the point. My professors, are you there?
Mr.
Yes,
Akman.
Yes, my professor. I should say it again.
Yes, please.
Okay, so I said that what you have here, if you are you concluding with this? Is this what you were asked to find? This is only a means to an end. You are not concluding. So if you came to write minus 2 over, you substituted directly without checking whether this will be positive or not. Okay, that is okay. There is no issue with that in this situation. Okay, I can write it this way. This implies that this is equal to this. Okay, because I know that this is not my conclusion. My conclusion, I will introduce a first term which is positive. So if I introduce that first term, you realize that that's my positive first term. Okay, this will not be a first term for me to say that it should really be positive. But in terms of this should be the first term. I don't know if you get my point. If you were
Yes,
asked to find this and you are concluding with this really should be your first term because you cannot start with the negative term unless otherwise stated. Point well made now. Okay, all
yes,
right. So if that's the case, then we are going to move on to the second one, the B. I have the solution there just to save time. So I will walk you through the solution. So take notes. All right. So here again, the only difference here is that, okay, so first of all, ask yourself proper or improper. And obviously, degree of the numerator is 2. That of the denominator again is 2. So improper. So once it's improper, we cannot straight away go to the denominator in writing the identity. We cannot write the identity. So we have to go through the long division to get our quotient plus the remainder over the divisor. However, we know we are going to go through the long division. And in the long division, we know our divisor, okay, and dividend, they should be written out completely and they should be in the standard form. You shouldn't see any brackets. Okay, so numerator, which is the dividend, is in the standard form but not written out completely. The denominator is not written out completely, it's not in the standard form. So we have to come and remove the brackets. So you should know how to expand this. Okay, what you have here. So in this case, you can do it mentally or you come and do your expansion as a rough work. So that will give you s times s, that will give you s squared. Okay, s times minus 1, that will give you minus x. 2 times s, that will give you plus 2x. Okay, then 2 times minus 1, that will give you minus 2. So in effect, after expansion, combine like terms, that will give you plus x minus 2. I do it mentally. It will be this time, this which will give you s squared. You have 2s terms. One will come from 2x and one will come from minus x. So that will give me plus s. Then this time, this will give me my constant. So I can do this one mentally. Okay, however, if you are not matured, do it this way, import your result. But in that case, this becomes your rough way. Don't forget to strike it out. Okay, if I forget, I know I've told you, so you will not forget to strike out your. Okay, so now you can set up. your long division. So your divisor is written out completely now and in standard form. However, your dividend is not. It's standard but not written out completely. So you introduce that term just as we did in the previous one. Okay, you go through your long division and you end up getting this as your quotient. So did I say quotient? This as your quotient, this as your remainder. Okay, your remainder here indeed is a remainder. 8 degrees is lower than this. So we were supposed to stop there. So it means what I have here will be equal to the quotient plus the remainder. And you can see that, look at what I did here. In writing my remainder, I swapped the terms. Okay, because I know I'm supposed to start with the positive terms, okay, for it to look pretty. So my expression in the numerator should start with a positive term if I do have a positive term. So I started with a 5, then minus the 2x, all over. And you can see that at the normal circumstance, it should have been all over this. But because I'm matured and I know that I will take this one, okay, and come and write the identity, which will involve the factorization, which will take me back to this. Okay, I will straight away write the factors there. So that when I take it directly. I don't go and factorize anything. You get it? Otherwise, you can still write the s squared minus plus s minus 2 in the denominator. But when you are taking it, you take it and the next step will be where you factorize the denominator. So that will be one more step. You get my point? Or I should come again. Is my point well made, or I should come again? Hello, my professors. You are not responding. Is my point well made, or I should come again?
This come again.
I should come again. All right. Okay. So I said, the normal circumstance, it should have been your remainder, which is minus 2s plus 5. But I don't want to start with a negative term once I have a positive term. So that will be 5 minus 2x all over your divisor. And your divisor here is s squared, okay, plus x minus 2. Okay, so it will be this one plus this. Ordinarily, that's what should have been there. Then you come and write, taking this with the denominator being s squared plus x minus 2. Then you will now come and write equal to 5 minus 2s over the factorization. But I know that my divisor, this one came in its factorization. I only expanded to help me do the long division. So once I'm through with the long division, I can go back and substitute exactly what I have there. It's because of the long division that I expanded this. Other than that, I had my denominator to be in the factorized form, which I needed, because that will help me split or get my factors. Sorry, my fractions. You get the point now. So come and take this. Okay, then you know that with this one is proper. Always after writing it this way, if you take this, this will always be proper. So go to the denominator. Here it's factorized. So or you have two linear factors. So I can write the identity. Each factor, okay, will have a fraction. So s plus 2 denominator, numerator will be a constant. Okay, s minus 1's denominator, numerator will be a constant because linear. So come and take the single fraction, you know, at this point. So you've written the identity of your rational function, the second one. Okay. So at normal circumstance, if you were asked to write this, the partial fraction identity of this, then your answer would have been, therefore, what you are given here to write its partial fraction will be equal to your quotient, which is 2, plus the identity of this. So that will give you a over x plus 2, then plus b over x minus 1. So if we're asked to find the identity, this is where it will be identical to, don't forget, this is where you end. But we are not asked to find the identity, we are asked to resolve. So we need to go and find the values of this and that, and we are done. And that is what, okay, is bringing in, okay, what we are doing here. LCM, okay, at this point, we should all be able to continue. So you equate the numerators, and this is what you are equating. Remember, it is this that you are finding the values of a and b, not the original one. So is this numerator here being equal to the numerator here? Okay, you substitute. If s is equal to, okay, I could have gone for 1 because that would have been the smaller or the yes value. Okay, but I want to move this way. Okay, so s is equal to minus 2. You substitute. Okay, simplify. You get a to be equal to -3. If s is equal to, you equate this one to 0, so that will give you s equal to 1. Okay, you substitute. So because you have two unknowns and you have two distinct linear factors, it means if you substitute these values, okay, you have two, from the factor, you end up getting whatever that you are. So you don't have to go and settle on any liberty values. So at this point, if you continue, this is what you are supposed to get. You write it again, divide. So b will be equal to 1. So this implies that what you were resolving will be, okay, a. You can start with, a was negative. So, okay, I decided not to start with negative. Otherwise, you can start with negative, I've told you, because that will not be the first term in your conclusion. But for consistency's sake, okay, that's the more reason why I started with a positive, so that you don't forget, okay, in a situation where you are not supposed to, okay, you are not supposed to start with a negative in your conclusion. So this minus what that, but overall, therefore, this will be equal to, remember the quotient should come, so 2, then plus the resolution of what you have here, which is what you have there. So that becomes your final answer. Point well made.
Yes, sir.
Yes,
Okay,
please.
very good. Now, if you look at this question, you can see that this question is very similar. Okay, can you see this was the assignment that you did? Okay, where we realized that we could use, okay, the substitution method. Okay, but again, before we solve that one, okay, I walked you through the solution. I told you that this is improper. So if it is improper and you don't know the substitution approach, because in this case, the denominator allowed for the substitution approach, it satisfied the condition for that use. Okay, and if you don't know that one, and you want to use the identity approach, okay, in that case, if it is improper, it really matters. Remember, I said the substitution method, it doesn't really matter whether what you have there is proper or improper. So we are going to handle that one from, okay, the improper perspective, assuming you didn't know the substitution. But if you have this, always use the substitution. I've advised you already. So let's go and look at that one, okay. So if you want to use the identity approach, not the substitution approach, then this is the way to go, how to carry out your presentation. And we will see whether we'll end up getting the same results. Okay, and check the validity, okay, or the essence in that advice that you are giving. Use the substitution method. Okay, so now let's see. Okay, obviously this is improper. Okay, because degree of numerator will be 2. That of the denominator, if you expand this, will be 2. Okay, so this is what, and I'm expanding because I know once it's improper, okay, I have to go through the long division, and in the long division, I should get my polynomials, numerator, denominator, all of them written out completely in the standard form. So that's the more reason why it informed the decision to expand this. I can't use this to get the exact division for the, divisor for the long division. So I expanded. So your first step is to expand the denominator, which you have. Okay, and that will help you. You expanded because of the long division. So it will help you carry out your long division. So as for long division, we are all experts. Okay, so now look at this situation. You can see that this is negative. All the terms here are negative. So in that case, it will be your quotient equal to 1 plus the whole of this. You can't, okay, here, this is negative, this is negative. So you are compelled to write it in the same form. If this was positive, you would have written that as 3 minus 4x. So you maintain this over what we have. And you can see that when I was writing the divisor 2, I didn't write this. I wrote, okay, the original divisor, which is already in its factorized form. Other than that, if you come and write this, you have to go and factorize. Okay, so take note. But if you write this and you are going to factorize, you don't go through the factorization process. You should know straight away that, okay, the factorization will be what you expanded. So you write what you have here to replace it. Okay, so at this point, you come and take this. So you take this, you go and write the identity of this. And this one has a repeated factor. Okay, so even, hello, Prof. Gabi.
Sir, please, when you were rearranging it so that it become 1 plus -4x minus 3, Why didn't you change the plus there to minus?
Okay, you can change the plus here to minus, but you have to be very careful. If you change the plus here to minus, then everything here should be positive. So what you have is the same as 1 minus. In that case, it will be 4, okay, x plus 3 all over x plus 2 all squared. If you change this one to minus and you don't change this, you are doomed, because when you are expanding, the negative will only affect the first term. So in actual fact, what you have here is the same as negative out, okay, 4x plus what, 3 all over x plus 2 all squared. So it's at this point that because you have plus here, this will come and make this one negative. Then you come back to this. Okay, but to avoid this problem, that's the more reason why I didn't change. Because per experience, I've realized that, okay, students will usually change this one to negative and maintain this one. Okay, this one be positive and maintain the negative here, which obviously will be wrong. So if you want to change this one to negative. I hope you are with me. However, if you change this one to negative, okay, if you resolve this, which will give you more than a term, when you are going to substitute, you have to put it in brackets so that the negative will affect each of the terms, and equally you will see that it will be more work. I don't know if you get my point.
Yes, sir.
So that's the more reason why, not because I'm lazy. Okay, yes, you have to be hardworking, but you have to work smart as well. Okay, so I decided to work smart here. I didn't bring the negative here, because if I bring the negative here and I go and find these two values and I come and substitute, it will be minus. I can't straight away write, okay, what I have there, okay, because it's being preceded by negative. So I have to put it in brackets so that the negative will affect that. So that will be more work, like I said. So I just reiterated for those who didn't get the point. So take this, if all of them are negative, don't change it to positive. Work with whatever that you have here directly, because that's not your conclusion. Okay, take this one out, which will give you the exact numerator and the exact denominator, your remainder, then the divisor. Then now, okay, you go and find. So you know how to proceed from here. As for, even at this point, okay, someone could have used the let method, the substitution method. Can you see that? Someone, you could, so in this case, you can combine the substitution method and but I've told you that the ideal method is the long division. But because I want us to go through the identity way, that's the more reason why we are doing this. So we don't have to see any substitution anywhere. But if you get here and you want to use substitution, it's allowed. Please take note. That will give you the resolution of this one into partial fraction. Then you come and add that one to the one that you have there. So you go through the steps here. Here you should be able to follow. Okay, your linear factors will be s plus 2. So only one linear factor. So if s equal to 2. Okay, after that, you've exhausted your linear factor, only one linear factor, but you have two unknowns. So this should tell you that one linear factor will not help you, will not be enough, I should say, to get your two unknowns. So you have to settle on a liberty value. And we start with our first liberty value. 0 has not been used. So you use, none of them will vanish. But because you know B, you substitute and you solve for A. So on that note, this will be the value for your A. But you can see that in this situation, I didn't conclude, or I didn't go through the partial fraction of this. I mean, I didn't write this. Look at the other one. Okay, I didn't write this before moving on to this. I'm matured. So straight away, I can come and write my quotient in this one, which is 1. Okay, then plus the values here, I substitute the values, then I'm good to go. So my quotient 1, my A minus 4. So here I know that I can start with the negative because it is no, okay, more the first term. So minus 4 over, and your B gave you 5. 5 over this. Let's go back and check whether we had the same result. Or those of you who have it, did we get the same result when we use the substitution approach? So quickly, let's go back and check. Okay,
Yes,
so
sir.
this is it. Is that not it? So now look at this. We even a page, I mean, just to this two side. Okay, we didn't exhaust the presentation. Okay, look at what we did here. Okay, look at that. Okay, the volume of work there. Oops. Okay, so you can see we exhausted this, we went beyond, and we wrote a lot. Okay, take notes. And in this one, because you are going to do your long division, which could be wrong, it means you are doomed. Okay, so when it is wrong, so it's safer to use the substitution method when the substitution method is applicable. Is that clear?
Yes, please.
Okay, very good. So that will be it for what we have here. Okay, so on this note, you should be able to try this. I think I'll give this one to you as an assignment or so. Okay, you try this, okay, as your assignment. This one, once it's in green, you know that possibly you see it in your class test. Any questions on the improper fraction situation? Okay, Prof. Mamiya.
Please, can I take a screenshot
Oh, if
of the
not,
first slide?
this one.
Yes, please. Thank
Okay,
you.
I will even send it to you by close of day because we are rounding up like that. Okay, all right. Okay, so apart from that, any issues? We are all fine, right? Okay, all right. I'll take your silence to mean yes. Okay, so on this note, okay, thank you very much for making the class very interactive, and I believe the class was a success. God bless us all.